Right now, beneath the soil of every plant you own, something is happening that you will never see, and it's far more deliberate than you'd believe. The roots of your plant are not just sitting there soaking up water, they are exploring, measuring, choosing, and even recognizing who's growing next to them. The hidden half of your plant, the half buried in the pot, is making decisions all day long. You probably think of roots as simple plumbing, pipes that pull up water and hold the plant in place. They're nothing of the sort. The root system is the closest thing a plant has to a searching, problem-solving brain, and it's working underground in complete darkness while you go about your day. Once you understand what it's actually doing down there, you'll change how you pot, water, and even arrange your plants. By the end of this, you'll know exactly what your plant's roots are trying to accomplish. And the fifth thing they do is so surprising, it suggests your plant can tell the difference between family and a stranger. Let's start with the search. Imagine the soil under your favorite houseplant as a hidden world where roots are on the move, not just growing, but hunting. Every day they are probing the darkness, searching for pockets of nutrients like tiny underground explorers. When a root tip stumbles upon a rich patch of nitrate or phosphate, it does not just keep going, it changes strategy. You will see, if you could peer through a rhizotron, a clear-sighted chamber scientists use to watch roots in action, how the root system suddenly branches out, sending side roots into the jackpot zone. This is not random, it is a calculated response called foraging precision. In split-root experiments where a plant's roots are divided between two soils, one rich, one poor, the roots in the fertile side grow up to twice as many branches. The less promising side gets ignored. It is as if your plant is weighing the payoff before investing energy, zeroing in on the best returns. Dr. Jane Hodge, a soil ecologist, puts it this way: roots are incredibly selective. They sense tiny differences in nutrient levels and will steer growth toward the richest patches, even if that means abandoning other areas. This underground hunt shapes everything above the surface: how fast your plant grows, how lush the leaves look, how well it survives a tough season. Before roots can steer or sense gravity, they're already making choices, gambling on where to branch next. And every one of those choices starts with the silent question: is this spot worth the risk? Roots don't just grow wherever the soil lets them. Each tip is equipped with a sophisticated guidance system, steering through darkness using built-in sensors that rival any animal's sense of direction. Deep inside the root cap, special cells called statocytes hold dense, starch-filled granules known as statoliths. Whenever you rotate a potted plant or tip a seedling on its side, these statoliths settle downward within seconds, pulled by gravity. Their movement triggers a rapid cascade. Calcium ions surge, and the root's growth machinery pivots, redirecting the tip to curve back down into the earth. This is not guesswork. It is a mechanical calculation at the cellular level, repeated thousands of times as roots tunnel through unpredictable soil. But gravity is only one part of the equation. Roots also chase water, often overriding gravity's pull when moisture is scarce. This behavior, called hydrotropism, follows a separate pathway from the statolith system. In Arabidopsis, scientists have identified the Mizu-Kusei gene complex, which lets roots sense even faint differences in soil moisture. When one side of a root tip detects more water, growth shifts in that direction, bending the root toward the wettest patch. The two systems, gravity and water sensing, work in parallel, sometimes competing, sometimes cooperating, always recalibrating the root's trajectory. As plant physiologist Dr. Elena Ruiz explains, roots are constantly integrating signals from gravity and moisture. It is a dynamic negotiation. Sometimes gravity wins, sometimes water does, but the root always finds the best path for survival. Every twist and turn below the surface is the product of these invisible decisions, ensuring that your plant's roots never wander aimlessly, but navigate with purpose and precision. The pot you choose is more than a container. It is the entire world for your plant's roots. When space runs out, roots circle the edge, weaving tighter with every lap. This is not just a cosmetic issue. Circling roots can squeeze their own vessels. cutting off water flow by as much as 40%. That means even if you are watering faithfully, the leaves might wilt or yellow because the roots cannot deliver what is needed. Horticulturists see this all the time, a healthy-looking plant above, but a root ball below that is tight as a fist, sometimes even trapping pockets of soggy soil that breed disease. Oversized pots bring their own risks. Too much soil around a small root system holds extra moisture, starving roots of oxygen and raising the chance of root rot. Studies have measured 15 to 30% higher loss rates in plants moved to pots that are much too big for their roots. The sweet spot is a pot just 20 to 30% larger than the current root ball, enough room to grow, but not so much that the roots drown in their own home. The best plant doctors start with the roots. They gently tip the plant out, check for white, firm roots, and look for any circling or brown, mushy spots. If you find roots spiraling the edge, loosen them before repotting, giving them a chance to explore new territory instead of repeating the same suffocating pattern. Next time leaves look tired, remember the real story is almost always happening below the surface. Long before a thirsty leaf droops or a stem softens, your plant's roots are already on high alert. Hidden in the dark, these roots act like a silent early warning system, able to sense when water is running low or when salt levels climb too high. They don't just sit and wait for trouble. They send a rapid chemical message up the stem, hours before the first wilt appears above ground. The key player in this underground alarm is a hormone called abscisic acid, or ABA. As soon as the soil starts to dry, roots ramp up their production of ABA and release it into the plant's veins. This hormone travels upward, reaching the leaves and triggering tiny pores, stomata, to close tight, conserving precious water. Physiologists have measured this signal racing ahead of visible symptoms, sometimes by several hours. Dr. Aisha Kim, who studies plant stress responses, describes it simply. Roots are the first responders. They detect drought before the leaves ever know there's a problem. This chemical warning system means your plant is always scanning for threats below the surface, acting on information you can't see. That's why a plant can look healthy one morning and show signs of stress the next. It's been quietly bracing for trouble thanks to its roots' advanced notice. The next time you spot a drooping leaf, remember, the real crisis started underground, and your plant's roots were already working to keep it safe. In a greenhouse packed with pots and possibility, plant biologist Susan Dudley set out to answer a question most people never think to ask. Can roots tell who is nearby, who is family, and who is a stranger? Her experiment used the Great Lakes sea rocket, a tough little annual that scrapes by on sandy dunes. Dudley's team planted pairs of seedlings, some siblings and some unrelated, side by side in identical 12-liter pots. For 28 days, they watched what happened beneath the soil, tracing every root that reached into the shared zone between neighbors. The results were startling. Sibling pairs overlapped their roots by about 30% more than stranger pairs, a difference so sharp it held up to statistical scrutiny, with a p-value less than 0.01. Dudley explained that this was not just random tangling. Siblings seemed to cooperate, weaving together underground instead of battling for space. The design was simple, but the outcome upended old assumptions. Roots, it seemed, could sense who was nearby and adjust their growth accordingly. This experiment did not just add a footnote to plant science, it forced a rethink of what roots might be doing, unseen, in every pot and patch of earth. Claims of rootkin recognition have sparked a wave of debate and careful retesting. After Susan Dudley's sea rocket findings, other research teams tried to reproduce the effect in different plants and under stricter controls. In 2011, Biedrzycki and Bass ran sibling versus stranger experiments with Brassica rapa, but saw no clear kin advantage. Their results suggested that hidden players like soil microbes might be the real messengers underground. Donahue's 2014 work took this further, growing sea rocket in sterile agar to wipe out microbial influence. When the microbes disappeared, so did the kin effect. Kohler's 2016 study swapped the soil microbiome between sibling and stranger pots and watched the pattern flip entirely. Suddenly, the supposed kin benefit moved with the microbes, not the roots themselves. These findings hint that what looks like root-to-root communication might depend on a shifting network of bacteria and fungi recruited by root exudates, chemical signals that roots send out into the soil. The scientific conversation now lands on a more cautious note. Kin recognition exists, but it is context-dependent, and the soil's living community may be calling many of the shots. This is how science moves, one bold discovery, followed by years of careful checking, new questions, and a reminder that the world beneath your plant is even more complex than it first appears. Right now, your plant's roots are hunting, sensing, and even recognizing kin, reshaping what happens above the soil with every silent choice. The next time you check for wilted leaves, remember, the real decisions start underground. The science is still unfolding. Subscribe for more hidden stories just beneath the surface.